This work is about the possibility of implementing a thermotolerant yeast, which is Cleveromyces marxianus, in the first generation bioethanol process we have in Brazil. So what we have today is Saccharomyces cerevisiae as the main yeast fermenting sugars into ethanol. And to do this, we need to cool down the fermenters because there is heat production, and well, there is a big issue with contamination because these processes are open. So if we manage to implement a thermotolerant strain, then fermentation will happen at a higher temperature, and this has the potential to decrease the contamination levels. So we can, for example, decrease the use of antibiotics. And cooling costs and water usage for cooling can also be decreased, and also the use of sulfuric acid when the cells are treated in the recycle step. So there is this potential to improve the process by changing Saccharomyces cerevisiae for a thermotolerant yeast like Cleveromyces marxianus. We haven't yet succeeded to get to the final, let's say, results, because we first need to investigate whether Cleveromyces marxianus presents some important characteristics. So it has to be able to grow under full anaerobiosis because the process is anaerobic. It has to tolerate high ethanol concentrations, and it has to tolerate low pH. And what we are doing in this project is to start by screening a lot of Cleveromyces marxianus strains, choosing the best ones, and making the experiments necessary to demonstrate that they are indeed capable of growing anaerobically, to tolerate ethanol, and to tolerate low pH. So, but the main issue we are working on now is on anaerobiosis, which is something that is actually very difficult to achieve in the lab.